Hey, if you clicked on this video, then that means you have some issues regarding how to convert a binary number to a denary number. Well, no worries, because in this video, I'll make sure to get rid of that issue once and for all. And without wasting your time, let's start with the video, shall we? So first and foremost, what is a binary number to you? What does the term binary actually means? And by the way, I'm doing this on a whiteboard that I found online, and I'm writing this with a mouse because I cannot really afford a tablet right now. But anyways, let's continue. So what is a binary? Binary means zeros and ones. What is zeros and ones? It is a low-level programming language, or you can call this machine code, which only computers can understand. We give out instructions to the computer in high-level programming language like Python, Java, blah blah, and those programming languages are converted into binary data, which the computer understands and then carries out the instructions. And 0 and 1 means on and off. And what is denary then? Well, denary value is a whole number. What is a whole number? It is an integer like 11 or 12 or 15 or 99, 100, like this. So yeah, so what is denary number? Denary is a whole number or integer number. And what is a binary data? Binary data is zeros and ones. It is a machine code. And so now I will tell you how to convert binary data into denary value. So let's start the video. Well, I meant let's start the calculation, not video. I already started the video. Well, then for number one, we are going to represent this 8-bit binary data into denary value. And so what does 8-bit mean? So 8-bit typically means 2 to the power 7. So that means it can represent 128 characters if I'm not mistaken. Wait, let me double check using a calculator. Yeah, 2 to the power 7 is 128 characters in total. We can represent using 8-bit. So what is 8-bit? So in what should I say? In our calculation, we usually start from 2 to the power 0, which is 1, and anything to the power 0 is actually 1. Then 2 to the power 1, 2 to the power 2, then 2 to the power 3, and what is lastly is 2 to the power 7, which is 128. Now why am I saying all this? Because this is truly important when we are going to convert uh, binary data to a denary value. So firstly, what do we actually have to do? What we have to do is create a table. What table? Now I'm going to show you what kind of table I'm talking about. Let's start from left. Since the maximum characters we can represent is 128 characters, and what is this? 2 to the power 7. You don't really need to write 2 to the power 7. You can just write 128. And what is next? 2 to the power 6, which is 64. And then create some barriers so that it's not stuck to one another. And then 2 to the power 5, which is 32. Basically it's getting half each time. And then what's next is 2 to the power 4, which is 16. And then 2 to the power 3, which is 8. And then 4, and then 2, and then lastly 1. What is 1? 2 to the power 0. What is 2? 2 to the power 1. And what is 4? 2 to the power of 2, right? So once you are done creating this table, what I want you to do right now is just put down the values, like the binary values that you have. If the question asks you to convert binary to denary, then always remember that they will give the full binary value. You just need to convert it to the denary number. So basically the first digit is 0, so I'm going to write 0. So this is done. I'm going to cross this out. Bruh, I literally mistakenly closed the entire tab, so I had to rewrite this again. But anyways, let's continue. So we're going to write 0 first, and then we're going to cross this out, and then we're going to write 0 again because next is also 0. Then 3 more zeros, 1, 2, 3. 1, 2, 3 zeros done, and what is left? 1, 0, 1. So 1, 0, 1. Done. Easy, right? Just plot them out, and then the values which are 0, you don't need to do anything with them, because what you have to do right now is just one simple step. Whichever value has 1 beneath them, add them up, like total them, like basically create a sum of them, like 4 plus 1. Why am I doing 4 plus 1? Because they both have 1 beneath them, so in after we add them up, it's 5, right? We are not adding up the 0 because zeros, anything uh, multiplied with 0 will always be 0, right? That's why we do not do anything with them unless it's a power. uh, Anything to the power of 0 is like 1, right? So yeah, that's that. Well, anyways, let me repeat everything from the beginning. So firstly, create a table, and the create table must be in order from starting from 2 to the power 7 up to 2 to the power 0, starting with 2 to the power 7. And then you have to plot the denary's value between each point. So for 128 it was 0 because the first denary binary was 0. Then 64 it was also 0. For 32 it was also 0. For 16 0. For 8 0. But in the case of 4 it had 1, so I'm going to write 4 and then 0 again, and then lastly 1. So I'm going to plus 4 and 1, so in total I'm getting 5. So 5 is the denary value for this binary number, for this 8 this 8 bit uh this 8-bit binary is representing 5. So yeah, let me do another math so it's going to be easier for you to understand. Well, now do you remember what you have to do first? If not, no worries, I'm going to write it now. 128, 64, the 6 is too big, 130, what I'm saying, 32, 16, 8, 4. What's wrong with me, bro? Anyways, 4. I'm never going to get used to writing with the mouse. 4, 2, and then lastly 1. So I'm done creating the table. Now what I have to do is, oh, by the way, my table is not beautiful at all. So if you want, you can customize your table a bit, like make it more better looking, I guess. If you want to, that is, it's entirely up on your preference. And sometimes you don't even need to create a table actually, if you are like well accustomed converting binary data to a denary. Anyways, let's plot the binary data. Firstly is 0 and then 1 and then 1 and then 0 0 1 0 0. Ignores all the 0 and just add all the ones together. 64, my bad. So 64 has a 1, then 32 has a 1, and then 4 has a 1. How much are this total? I believe it's 100. Let me double check. It should be 100. And yes, it is 100. So by adding these three numbers, I got 100. So the denary value for this 8-bit binary is 100. And that's all. Yes, it's that easy actually. It's just now you need to practice a bit, and then after doing 5 to 6 maths maximum, you will get accustomed to it, hopefully, and then you will be able to convert any binary data into denary value if the question asks you to do. And of course, I'll be creating more videos related to computer science, including physics and also maths. If you want to check all the videos, make sure to subscribe to our channel and turn on the notification bells for more contents. And I'm not fluent in English. I keep studying time to time because I rarely talk this much in anywhere. I'm more of an introvert person, but I will try to share my knowledge with everyone so that everyone can be a better version of themselves in terms of studies. I'm not going to help you guys in other aspects of your life. You guys can do that yourself. But if you need help anywhere, just DM me on my Instagram. But anyways, that's all for today. I'll be uploading videos related to how to convert a denary to a binary and then hexadecimal and so on. So yeah, stay tuned for that, and for now, peace out.